All right, hey there, ladies and gentlemen, boys and girls. Today I'm going to talk about one of the cool benefits of understanding Bohr models and being able to use them that Niels Bohr used when he created them was this understanding of what we call excited electrons or excitation. It's exactly what it sounds like. The electrons get very excited. They get really excited, like really jittery, and they move around really, really fast. And they actually can move up and we'll talk a little bit about what happens because of that. This is the reason why fireworks give off color or you see flame, right? You see fire is because of what is happening here. So we're going to talk about that, or I should say light coming off of fire. All right, so I'm going to talk a little bit about that here. So I start off with, we're going to do this example. I wanted to use an easy atom, easy one to draw with Bohr models, and that's lithium. All right, so first things first, let's think about what we have with our Bohr model. All right, we have 3 protons and 4 neutrons in our nucleus. Remember, the purpose of a Bohr model is to really look at the electrons. So we have our 1, 2 in our first energy level, and we have 1 valence electron in our second level. Now remember, each energy level is a certain amount of energy. It can hold more electrons. First one is the weakest, then it gets to a second energy level, and there's not enough energy here to even get to the third one, but there is that third energy level. It's just empty right now. All right? There is that third energy level. It's just empty. All right? So what actually can happen is if a lithium atom is exposed to an amount of energy, all right, from a heat source or an intense light source, basically if some sort of energy comes in, all right, and adds energy to those electrons, those electrons can now upgrade to a higher energy level, right? Basically, that electron gets hit with a certain amount of energy. That electron becomes what we call excited, all right? And what will happen is, all right, that electron will then jump up to the next energy level. All right? Because it's got that extra energy to perk up and it's kind of temporarily upgrading to the next energy level. Just draw my Bohr model real quick. All right? So that second energy level, because it was the only one in there, now empty, it's moved on to the third energy level. All right? It's on that third energy level, and this is what we call it went up from here to here. All right? We call this an excited electron. It's called an excited electron, where it jumps up to the next level. All right? But it only can do that for a brief moment. It gets this temporary burst of energy. Think it's almost like a little sugar high. It jumps up. It's very excited. It's got all that sugar running through it. But anytime you have a lot of sugar, what eventually happens is that you get brought back down. All right? And it's the same thing that's going to happen here. Right? All right. So what happens is we have it jump, we get excited, it jumps up, but then eventually it's going to come back down. And so energy had to come in to make it go up. So when it comes down, the reverse happens. Energy is then released. In the case of fireworks, this is caused because of this is what causes fireworks to look bright. Lithium, I believe lithium, when it is in a firework, like lithium compounds, it gives off a red firework color. All right, that energy could be in the form of heat, sound, light. All right, sometimes you can get enough energy. If you add enough energy, you can even go up 2 energy levels. That's very excited. All right, and that excited electron will then come back down. And when it comes back real hard, it's going to release even more energy. So the colors of like blues and purples, those are higher energy colors. That's more likely to release a higher energy, or when that energy is released, if it's a high amount, if it jumped down 2 or 3 energy levels, it's going to more likely release some of those energy. All right. If it maybe just 1 energy level, it's more likely to be a red or an orange in fireworks. And it's all just this idea of understanding about we have different energy levels for each of these electrons, going from the weakest and next stronger. If we can put in energy, we can get them excited, upgrade them. And when they're up there, they're doing great, but they're very quickly going to come right back down. And when they do that, it releases that energy. All right. All right, that's pretty much it. Just kind of understanding how that process of what we call excitation, which is just a fancy word for saying when we make an excited electron that releases energy, that's this process here. Start here, and then this happens, and then this happens. All right, that's it. All right, this was a pretty short one. All right, good luck, and may the science be with you.